Alright, so today I want to work on collision detection. Or at least optimizing my collision detection code. Because right now my raycasting code is very inefficient. So I need to optimize it. So I'm going to work on that today. Test. Wow, I think you're the first one in here. I fixed the math for my bullet raycast too. So now it actually fires out of the barrel, which is kind of cool. So like if the gun's shooting off to the side, you can see the bullets go where the reticle is, which is pretty sweet. Nah, it's sick. It's sick. Cause look, then the recoil actually like follows the gun. See, it's like random. But if you zoom in, you know, it's spot on. Yeah, I mean, I can see the argument both ways. I think it can still work though, so I'm gonna try it out. We'll see. Because shooting it out of the center of the screen is actually easier. So if it feels like shit, I can just go back to the other one. The other way. But I mean, just like flying around, I think actually feels pretty good. So I don't know. I think it might be fine. But anyway, yeah. Do I have advice to a new C++ learner? I don't know. I don't know. Yeah, exactly. Make stuff. Don't stop making stuff. Don't over-engineer stuff if you don't have to, as well, is a good piece of advice. It can be hard to gauge, though, what over-engineering is if you don't have experience over-engineering something, so I don't know. I guess C++ is a really complicated language, too, so my advice is that maybe you shouldn't try to use, like, every language feature, because it's just like overwhelming at that point. So like my C++ style is kind of basic C++ really. And that I do like a lot of C style stuff in my code. Just because I think some of the modern C++, I don't know, ways of doing things are a little complicated sometimes. So yeah. But yeah, I want to do collision detection because my raycasting is super slow. So I will demonstrate that here. Maybe I should make a little example. And I think this is something I can get done in a few hours. So I only have about 3 hours tonight before I have to head out again. So let's see. Where do I do raycasting? Maybe I just need like a module in here for like collisions. Oops. I always call my header source file things a module. Oh, I keep doing folder. New file. Collisions. So let me just get some boilerplate code working first. Actually, this might be a struct or a class, believe it or not. So we have a, what do we have? I guess for now I'm just gonna make this thing a list, even though I'm gonna refactor this. core list. So we have a list of float 3, so these are like our vertices. 10 years. It's crazy how fast the time goes too. It's like you blink and next thing you know, it's been 10 years since you worked on some project. It's like, what? What happened? Anyway, so we need like an init function. It's my classic pattern. I have an init and a free. And we'll just do this. Implement in the source file. Okay. So then I'll have a function that's just like Raycast, I guess. Takes in array, and then I will return maybe like a struct here. We'll have a struct on this thing, or maybe for now we'll just return the built-in hit class. So I'm kind of like writing a wrapper around my engine's Raycast code, but this will be like for the actual project. So that returns. Need to include. Forget if it's geometry or 3D. I think it's geometry. So in the most basic sense, we're actually just going to directly pass through. What header is this in? Oh, it's in 3D. Of course it is. Yeah, it's very important, I would say. Very important to know data structures and algorithms. At least in like a high level sense. Because like obviously you can just use a bad algorithm and you can still make a game with that. It's just your game won't be performant depending on... I'm detecting against triangles because my level is made up of triangles. Do I think AI will take over programming? I don't know. I literally have no idea. My hope is that the answer is no, but like the answer is probably yes. Like, you know, if we're just gonna keep developing AI for like 100 years or 1,000 years, you know, eventually it's probably gonna get better than us. Will it get better than us in 5 years? I don't know. Probably not, because AI still kind of sucks even today. But you know, we're also one breakthrough away from it being really good, so, or I guess potentially one breakthrough away from being really good. All right. So my level has a collision. We'll have collisions here. So we will include and then on it, we will basically initialize this, and we'll make sure to free it. I'm going to put a to-do around here, just so we make note that this is temporary. Yeah, I do programming for a living. So I just do this for fun. I actually just got done working like an hour ago, so that's why I'm streaming now. All right. So where do I load the collisions here? It's like this. So I'm gonna do this twice, actually. Oh, this is annoying. Let's see. Yeah, the stream's gonna be shorter. I'm only gonna go for like 2 or 3 hours tonight, cause it's already like late for me. So. How did I prepare? I didn't prepare actually. I just kind of went in. I do a lot of coding just for fun, so I think that like just doing that as a hobby prepared me, I guess. And like with game development programming, you solve a lot of problems just by necessity of like game engines are complicated pieces of software. So I think I was like well prepared just by doing game development stuff. Okay, so I'm actually going to traverse this mesh. Let me just see though. If this is this used anywhere? I don't think it's used anywhere. What? So I'm not using the mesh anywhere. That's annoying. All right. I'll actually put the to-do here. Sorry, I might be a bit more focused today than I was yesterday, because I do want to get this done. So if I miss questions, I'm sorry. Yeah. Well, see, if you're 15, I'm 27 right now, so it's like, think about how much you could learn in 12 years, right? Like, I don't know, if anything, that's kind of inspiring. It's like, I wish I could be 15 again. Knowing what I know now, like if I had the access to like, I guess it kind of gets into the AI topic a little bit, but like I think AI is a really good tool for learning because it's just like a more efficient Google search in a lot of ways, or at least you can use it like that. So like that's what I think AI is really powerful for is like learning new information or just like knowing where to look for information. It's a great starting point. So like if I had access to that stuff back then, it's like, who knows how much better of a programmer I could be now after using that for 10, 12 years. So I don't know. All right, so what was I doing? So collision dot vertices dot add position. This is like really to do. Definitely remove this. This is just like hacky code. I just want to get the first version of this API to work, and then I'm going to actually optimize this by doing spatial partitioning. And I'll have some cool debug overlays of that, hopefully. And then, assuming I can get that all working tonight, that's the goal. Okay, so I think that actually all should work now. Let's just run this to see if we crash. We do crash. Triangles.free. Oh yeah, that's right. I didn't remove this. And this needs to be up here. I'm not sure how I'm gonna test this. I need to get an FAQ for the theme because this is a common question, which is it's nice that people like my theme. I don't really have a specific theme. It's just kind of one I've evolved over time. So like the main things I've done is I've changed the font to a font called IOSevka. And then I made the background darker. And that's pretty much it, actually. And I've moved the widgets around. So like I put the terminal on the right side. So I think that's like why it visually looks interesting. All right. So in the scene, I'm just going to draw... Let me see, where can I put some stuff? I'll delete this line test thing. Yeah, it's kind of what I'm working on for fun at the moment, is this little Counter-Strike style game. My music's really loud. Is the music loud on the stream? I don't want it to be like too loud for everybody. I had the problem yesterday where it was kind of loud. All right, so the ray is, let's see, equals, what's the function I have? It's like point ray screen point to world perspective. And our screen point will be a float2, which is the mouse X, mouse Y. And then the dimensions are float2, prefix, viewport, width, height. And then the point I is camera. I really should have these as floats already. And then, let's see. All right, so this is like the ray we're going to use to test for collisions, and then we'll go level. Is this a namespace? I don't remember. Or no, it's just a class. Okay. So if this succeeds, then we'll draw this as a line, I guess. Or maybe we'll just draw like a point on, we'll draw a point on the wall where this thing collides. What is happening? Hey, how's it going? Yeah, it already is networked. Sorry, I haven't looked at chat in a second. I'm just trying to grind out some of this code really quickly. And I'll answer some questions in a second. Or I'll do some demonstration. I don't know why I'm using doubles for this. Does it matter? I don't think it does. What failed? Oh, the game's running. All right, here we go. We have a sphere. Let me change the texture to something less insane. What textures can I use as a good example? Texture. I don't even know. We'll use the brick texture as my sphere texture. Okay, so yeah, I have collisions now, or at least it's raycasting against the world, which I already did have, but I just did a refactor on it. All right, so what was the question? Did you fix bullets going forward all the time? Yes, I did fix that actually. See now, let me get the mouse out of the way. So now the bullets actually come out towards the reticle. So like as the gun turns, this now I have this annoying thing in my mouse, which kind of ruins the demonstration. But the bullet collisions actually come from go towards the reticle out of the gun barrel, which I didn't have working yesterday, but I figured out the math problem. It was I had my coordinates, I had my axes messed up in my rotation matrix. And then the will it be online question. So yeah, I do have multiplayer working. It's very basic though right now. But you can see, like I already have the network code kind of implemented in a basic sense. And that like I can connect to a server. But otherwise it doesn't do anything yet, because I haven't gotten that far. Okay, so what's my keyboard? It's called a Ducky keyboard, Ducky 1, 2 or something, I think. I don't remember what brand or what model specifically it is. Let me make this dot a little smaller. And why is it rendering such crazy colors? Alright, I guess it has to be this shader. Yeah, let me show that. Let me get this thing not rendering anymore. I'll explain what I did with the bullet. The bullet raycasting. So I can full screen. I'm not sure actually. Maybe soon. So yeah, anyway, the bullet stuff, what I was trying to explain. So in the center of the screen, I have this like little reticle, the little white dot, which might be hard to see on the stream because of the quality. But it's not actually in the center of the screen. So if you watch, it like moves around when the gun kind of tilts around. And that's most apparent when I get close to a wall, right? Like you can watch how the dot shifts off to the side. Or like when I shoot, there's recoil with the way the dot moves around. Because it's actually like, it's basically a raycast from the barrel of the gun. And I am having my bullets, when I raycast them, when I fire, I'm having them go towards that point. So it's not always like the center of the screen like it is in a lot of first-person shooter games. And I don't know, I'm just experimenting with whether this will feel good or not, I guess. It just means that the bullets actually like have recoil that's tied to like the state of the weapon that you see, which is kind of neat. But yeah, yesterday I had my math broken, so I couldn't do that. All right, let's see how long it takes to do a raycast. So we can time this. We can just print this time. And there's some other stuff I'm printing I have to turn off. I'm actually going to turn this off entirely. I already have a profiler. It's just not doing anything. Like I can turn it on here. Oh, I'm not rendering it. Let me render it in this project. Why is this? What do I call this? Oh, it's manager. What? Here, let me look. Let me just go to my other project. I do have a profile built into the engine already. So this is my other project. It's like my actual game I'm working on. It's my Terraria clone game. But I have a profiler that does like a nice frame breakdown, which is kind of neat. You can like see how much time I spend on certain things. Always have to play with the water physics in this game. It's always fun. You can see this game is actually pretty well optimized. I'm doing all this in just basically a millisecond. 1.5 milliseconds. I don't think... Yeah, like I said, it's a release build, so it's optimized. Anyway, let me look at what I need for that, because I do want that in this project. I forget what I called the function to draw it, because I don't draw it by default, because it's like... It's up to the game to implement, to like actually hook into these things. Oh, here, I have to do this. That is true. The thing is, I'm doing a GPU readback for the water simulation. So it's kind of unavoidable to have hitching on certain frames because like there is just unavoidable latency in reading back data from the GPU. But like really what this means is that my frames are really cheap and those frames are expensive. So if I go back, we can see like, let me pause it. Oops, I didn't mean to print screen it. So like the best frame is, you know, 1/4 of a millisecond, but then the worst frame is like 4 milliseconds. And all of this time is spent doing the readback from the GPU. Because it has to synchronize, and then it has to do the data transfer, which is annoying. How did you learn compiling? Sorry. I'm like trying to both work and do stuff at the same time. How do I learn compiling? Because every time I make something, the biggest problem I have is the building and learning of APIs. I don't know what you mean by compiling in this context. Do you mean like... they are async. I've already thought of that. I've spent a lot of time thinking about this. It's about as optimized as it can be. It has to read back quite a bit of water state, so it's as fast as it can be on my graphics card. And I'm using I have my own abstraction layer over graphics, so I can support all the graphics backends. So yeah, it's like per API is how it's being done. But yeah, I do it asynchronously. So like I signal that like, hey, I want to do a read back, and then you know I wait until it actually, you know, until all the work has been done, you know, and the GPU is ready. So I'm not forcing a flush or anything. I'm not waiting naively. And it's double buffered as well, so it's just as fast as it can be. Do you mean like when you say compiling? Do you mean like actually like hooking up the C++ compiler? Because like the easiest way to get the C++ compiler stuff to work is to just use like CMake, the CMake build system, because that. I mean, CMake isn't easy because it's kind of it has really annoying syntax. You just have to like learn CMake. And no, I don't have my VS Code anywhere. All right, sorry, I'm gonna I'm gonna get back to this collision stuff briefly because I do wanna I have a lot of work I want to get done on this tonight. But I'll try to answer questions when I can. Okay, so yeah, so basically, what was I doing here? Did I ever print these times out? Yeah, so like the Raycast is currently taking on this level, which is hard to see. I don't know which one we're in. I guess hard to see because I'm spamming the console, but it's about 0.06 milliseconds for this level. And this changes by level, so like this one has more geometry. So like it's taking me in the debug build, so it's gonna be a bit slower, but it's like I'm wasting a 1/4 millisecond on a single Raycast, which is like really slow. And that's because I'm not doing any partitioning like of the world. I'm literally just testing every single triangle. And there's quite a few triangles here, so it's very inefficient currently. So we need to partition, and then only test the partition, like only test the I guess the partitions that the Ray actually can interact with. But yeah, brute force. It's not horrible, but it's not great either. So I at least want to implement some basic spatial partitioning of my like collision mesh, and then write just an algorithm that raycasts against the partitions. And I think that will work better. I'm not going to go super extreme because like you can really get extreme with your partitioning scheme. Like you could use like I guess an oct tree to like easily kind of hone in on which partition the Ray is interacting with. I'm not going to do that tonight. I'm just going to do kind of the first step of that, which is just break up the level into smaller chunks and then test against that. Yeah, that's what I was thinking. I was going to do, so my plan is I'm just going to have like, when I load in the level mesh, I'm going to have some defined like size that just, you know, defines how large a partition chunk is, I guess. And I'm going to just like generate this data structure, which is just a 3D volume of partition chunks, I guess. And then I'll just AABB test against those. And then if the Ray intersects one of those, I'll actually like perform the true collision test against the triangles, and then keep the, I guess the closest hit point would be the one I care about. And I could also, I guess, maybe sort it so I test the ones closest to the Ray first, but I think maybe that will just happen naturally. I'm not sure yet. We'll see. So yeah, that's what I'm gonna do. So basically, we need some concept of like, I don't even know. Okay, sorry, let me read the question. Where did you learn how to do that? I mean, I didn't learn this from any specific place. It's hard to answer that kind of question. It's like I learned every piece of this in sort of in its own, you know, individual. Like I learned this piece at a time, right? So like I didn't just have a resource that held my hand through this whole process. It's just been over the years I've kind of just picked up bits and pieces here and there, and then, you know, built towards this one engine, this one project. All right, so how do I want to split this up? I'll do this a gross way first. I'm gonna have a function on here which is like initialize init partitions maybe, and then I'll refine this later. But we'll worry about cleaning this up after we have it kind of working, because it's easier to clean it up after you have something working, because then you know what your needs are. So we'll just like note assumption is that the vertices list is already filled, because this will get filled when we load the level. But maybe I would supply this in as like just like a raw block of data or something later on. So what do we need? I guess the first thing I care about is getting like the min-max bounds of the level. So we'll have like a float3 XYZ min. Actually, it should be the opposite, max. I'm just kind of like winging this code because I've actually never written this code before. So like I don't know the optimal way of partitioning my geometry, but I know the theory of how I want to do it. So we're gonna do that. All right. So we have to first just loop over all the vertices and then store the min-max bounds, because we'll use this to determine how many partitions we need, which will be important for yeah, just knowing how many partitions we need. So Morton curve. I don't even know what that means. It sounds cool though. Let me just get something working first, and then I'll look into what can be done to make it even better, I guess. So I'm going to start with the naive partitioning implementation first. So basically when I know this, and we need some sort of constant in here, I'll just put it up. I'll put it in here maybe. It might be. I don't know. I'm just making a game. We'll see what it turns into. This isn't like, I'll note this project isn't like I'm not making this as like a commercial project or anything. This is actually like a demo for the engine. And I want to work on my netcode. And a first-person shooter multiplayer game is a good what am I doing float3 for? Is a good kind of project to do that. Sorry, I'm kind of thinking while I'm doing this. So the number of partitions in the x-axis would be the min minus the max minus the min, divided by partition size. And then we want to, I guess, seal this, right? Loot boxes. You can definitely make a game with C. A lot of people do that. Okay, is my math right? Max minus min divided by size. That seems reasonable to me. All right. So I guess what is our partitions? Our partition is, I guess, a list of partition vertices. It's actually, I suppose, a pointer of these, like a list of these. So we'll need to allocate those. What do I call this? Yeah, it's pretty much what it is. And there's a lot of common patterns you use as well. All right, did I mess that up? This is a pointer, so it's basically a list of this depth. And then I guess we will want to actually fill these partitions with triangle data. So we need some sort of indexing function. So let me add these in here. So that this can be, and maybe I should do size for these as well, instead of integer. I spelled partitions wrong. Partitions. How do you put the files in the code together? Put the render files. I don't know what that means. Basically, I mean, do you know how programming works? I guess is the base question. I don't know how to answer the question without giving various depths of explanation. So, all right. So we have our partitions. Now we need some indexing, and I'll just make like a helper function that does this. partition index is yeah, I wasn't able to stream earlier today because I was working. So, yeah. Unfortunately, I can only do earlier streams during the week, on the weekdays. So I guess I'll just do like X, partition X, or so how does this work again? It's like at any given index, I guess I could just make, I don't know, I do need to do the indexing. I can show the game really quick, yeah. I made a bit of progress, nothing too crazy. This is like where the recoil's at. I'm not sure how much is different from last night when you left. I fixed the raycasting from the barrel of the gun, so it actually like shoots towards the reticle now. So it wasn't doing that yesterday. So like you see it like shoots over towards the wall now. So it actually respects, I guess, the reticle position, which feels kind of good, I guess. Feels nice. Yeah, that's what I'm looking for. The secret sauce. Yeah, it's basically, this needs to just give me the index from it. So like get a 3D array index as a one-dimensional thing. What happened to my function? I deleted it, didn't I? Why did I do that? I clearly can't type partition. Oh my god. Yeah. Sometimes I type too fast for my own good. I don't know why I'm typing this. I can just copy and paste. I guess that could be static. I don't think I'd ever use this outside of this. Nice. Yeah, thanks. Yeah, I'll try to reliably stream on Sundays like I did yesterday. Throughout the week, it's really hit or miss depending on if I can get time or not. So, yeah. Hopefully that works out. Okay, return. Let me just verify. Yeah. Yeah, it makes sense to me. Okay, let me just add these because I know that these are what I need to add. And then you just step, a dimension down with each of these. So like this is my width, and then this one has to do partitions. Okay, cool. And then I also want a helper function. I'll just say make this a get just so it's more. So then this one will take in a float 3, a position, and then I'll calculate these from the position as well. Which is why I stored this min-max thing, which I didn't store here actually. It should be. Make sure that line is not massive. So then from this, I can calculate basically what I did here. But I don't need to seal this. Because I'll use this function to like get the partition from a triangle center point, I guess. And then wherever the center point of a triangle lands is basically which partition it ends up in. It's kind of my idea with this. Which I guess does put an upper bound of like how large a triangle can be before it gets split. Like you can imagine a triangle is like so large it actually falls out of a partition or something. So maybe I should add it to each of the, if any point of the triangle lands in any partition, maybe it should be added to that one. I'm not sure. Yeah, I'll just do an assert on that actually. Or yeah, I do have to clamp, you're right. Yeah, because if you're outside, then this would, of course. This is annoying. Yeah, because I guess I don't want to assert if it points outside. Yeah, okay. Yeah, let's just clamp. Yeah, because then this can't ever leave the volume, I guess. Which makes sense. And then, let me see, what was I thinking? Yeah, so basically now I can loop through all the vertices. Well, I'll loop through the vertices in, let's see. I'm just going to first just do a little assert here for my own sanity. I'm going to assert that there are actually enough triangles. Like, I don't have partial triangles or something, which I think should never happen, but I just want to make sure. So I'm just going to step one triangle at a time, basically. And then I'm going to do +0 just so it's symmetrical. I started when I was like 9 or 10, and I'm 27 now. So whatever year that was, it's like 2007, 2008, I think. But I only really got serious about programming maybe 10 or 12 years ago, when I was like a teenager. All right. I'm gonna do the center of the triangle as my deciding factor here, where this ends up. So then I'm just gonna call this thing partition. Eating dirt. Yeah. Okay, and then we will just add these points, I guess. I spelled partition wrong for like the millionth time. Partition. So now each little partition is its own list of triangles, basically. It is a list for now, yeah. This is the rough and ready version here. It's just a list of triangles, or list of points. So like I'm obviously like allocating here, doing some malloc, which is kind of dumb. All right, so let's see. I think I can just render these out as different colors. I'll do that as a first step. Oh yeah, I didn't. That's annoying. My search and replace doesn't respect macros, which is annoying. Okay, I can one-line this now. Yes, nice. And I actually have to call this. So we'll see if we crash or not. It's a good sign. We didn't crash. Let's run with the address sanitizer as well, just for sanity. All right. Nice. Okay, actually, I want to, as a debug thing, I want to render these just so I know what they look like. So I'm going to write a quick shader that can just render that format. So we need like a shader, just like shader position maybe. And I will take in a uniform. We'll give them a random color. Oh my god, I cannot spell partition. Alright, so we'll take in that. Oh, I should do this and this. Oh yeah, that's true, isn't there? It reminds me of there was like a game that had a problem like that, where like there was I forget, there was a funny video I watched where there was like a chance that the floating point, if it landed specifically at like a certain value, it like ended the level early or something. So there was like this glitch that happened just like 1 every million times if the floating point just happened to land precisely on like the like the .00 or whatever. So I guess yeah, that is a potential thing. I should fix that. I don't like the possibility of something like that just chilling here. Granted, this is like static level data, so I guess if I hit that error, I would always hit it. Well, no, because if I test for like an actual collision, maybe not. I don't know. We'll see. Okay, let's render these. So for now, let's do some like temporary vertex buffers for these. Or, I don't know, how do I want to render this? I'll just make a little draw debug class or function. This will just be some very rough debug code where I like write all the vertices every frame just because it's easy to do that. Where I just regenerate the vertex data every frame. Collisions. I just want to see that this actually worked. I need a supply account to this thing. Let's do like a large, a large number. I don't know. How many vertices should we have? My max will be like 10,000. I don't think I'm more than that in the partition. So if we'll lazy initialize this. All right. Yeah, I can show you what the game looks like. So this is a little first-person shooter game I'm working on at the moment. So it's like low polygon. And I've just been working on the gunplay stuff the last couple days. There's really nothing to this yet other than some basic gun movement. But I'm working on collision detection tonight, or at least optimizing the collision detection. Because right now on the left side, I have just printing how long it's taking for the raycast at the mouse. So like you can see as I move this little dot around, that's where my mouse is. And it's taking, right now it's taking basically 1/10 of a second to do that raycast. So trying to optimize that to be faster. How long have I been working on it? So this game is only like a week, 2 weeks old, of just a few nights working at it. But this is like one game within the larger engine I've been working on for about 2 years. So I have other games too that I'm kind of working on. So like this is my Terraria clone game that I'm making. This is one of my more serious projects, I guess, because I'm putting in a bit more effort into this one. So this game's been like almost a year. And yeah, the engine's like all from scratch, basically. So yeah, I have like a lot of projects just in here. Like here's like another little demo project where I render a globe. So I kind of have two things. I have the engine, which is like driving all of this. This is like the API. Like if you look, I'm doing graphics code right now. So like all this API stuff with like vertex buffers and everything, like that's part of the engine, and that's like code I've written just over time. And then yeah, this game I'm just kind of doing for fun, as like, in order to make the engine better, I need to actually like make games within the engine. Otherwise, it's like I just kind of twiddle my thumbs not knowing what to do next. So games kind of push the engine to evolve. So that's my idea with that, at least. Kind of what I'm working at. Oops, this should be in here. Alright, in theory, this function should just draw like a white version of the level. If this all worked, let me just... Wherever I draw the level in here, I need to replace that. So we'll just comment this out for now. Oops. Yeah. I'm not playing the Matrix. That would probably be helpful if I did this. Alright, so I see fully white, which looks like my level, which is a good sign. But let's color these just so we can see what's actually happening. Let's see. Let me just include... Let's have like a random in here, random.seed. We'll seed it with some random value. Oops. And then the color will just be some I kind of expected to see more than just one color. Let me see. Let me make sure this is working in render doc at least. All right. So it looks like we have one partition. So that can mean either my partition size is too large or I've messed up dramatically. Let me see. Partition. How many of these am I doing? I guess I don't know how many of these there are. It could be that I'm only having one partition because I didn't set it to the right size. Where's my terminal? So I have 8 partitions. So I should be seeing them go into multiple, which is kind of concerning. Am I shadowing something here, maybe? No? Alright. Interesting, interesting. What if I make it very small, like 32? Alright. It's going good. That's some crazy text. Crazy font you have going on. Am I not doing the partition correctly? Let's see. I wanted to print this out, but maybe that's a bad idea. Let me set this back to a sane number, wherever it was before. Let me just print the count of these. So it could be that they're all just going to 1. Oops. I just need to see where on the chain this is failing. Yeah, okay, so it's all going into the first one. So you see like 0 is getting all of the vertices. So that's interesting. Did I mess up? Let me draw. Let me also draw the bounds of the partition, just so I can get like a visual idea of where they should be. Which means I have to undo this, which is gonna be kind of a pain. I don't remember. How do I get the? How do I unpack? It's like I need to do the inverse of this. Or maybe not. I was won't worry about that right now. I must have something dumb going on here. Like it's only going into the one. This is gonna spam the terminal, but we'll just see what this is actually giving me. Oops. Let's get rid of the print in here. Yeah, I mean, they're all going into that. Oh, yeah, that's actually a good point. Yeah, you're completely right. Yeah, because I need to base these coordinates off of the relative position to the yeah, that's definitely what's going on. Yeah, because this position X, right? This is giving me, you know, a clamped position relative to the bounds of the partition, but it's not getting this like. I need to get these relative to the corner, right? So this needs to be what? Is that like plus the negative bounds or something? Or like minus the minimum? I should really just pull this out into like its own separate thing. But this would be something like this, right? Let me think about this for a second. Like if you can imagine if the minimum point is -64 and you're like sampling 0.0. 0 minus -64 would be 64, which would be within the range of, yeah, I think this is correct. We'll see. We'll see if this fixes it. I still think it would have went into like one of the other ones. Yeah, okay, yeah, you already said that. And I need to do the same for this, or center. Yeah, so this should get that, I think. Did I do that right? What's happening here? Oops. That didn't work. Oh, this should be X, Y, Z as well. It would help if I... Still doing it though. Right. But I'm in Visual Studio Code, so the breakpoints kind of suck in this. All right, let's see. What is my position X? Oh, let's go down to here, so we know like it's run all the code. All right, position What was my input here? 0, 0, 0. That doesn't seem right. What? Oh, it's this. I was shadowing, look. You're so right. Here we go, nice. Now we're, now we're talking. Man, I really need to, what's that warning to disable shadowing as like a, like I honestly, I never want to allow variable shadowing. Because this causes me these little bugs that you just don't see until like something stupid happens. I mean, there were multiple things wrong, but at least now it's kind of working, which is nice. Now, if I go to the next level, this is going to crash, so I need to remember to free these. So let me do a free partitions function really quick, which is just resetting this stuff. So what do I allocate here? So every list needs to get freed first. And this is, partitions count is a use size now, so that should be like that. All right, and then we need to reset these, which we do, which is great. These always get recalculated, so I don't need to worry about that state. All right. Yeah, so basically, if you just joined, what I'm working on is optimizing the raycasting, basically the raycasting against my level geometry. So yeah, all these colors are just debug at the moment to basically represent like the spatial partitioning of my mesh, like my level geometry. So when I do a raycast, what I'm going to do is I'm going to test basically against these little subregions. And that would greatly reduce the number of triangles that I test against. Because I can do like, I can first do an efficient test, like array against the axis aligned bounding box, which defines the partition. And then from that, I guess, you can just optimize the raycasting. You'll see in a second once I get more of the code in, but I want to clean some of this up as well. Briefly, and I'm going to reduce the partition size. So like if I make this smaller, we see we get more of these little partitions, which is what we want. And then I can go to other levels, but first I need to add the free function to this. So like here's another level where you can see like more of the partitioning going on. And some of these are so large, like it's actually it's just like a single partition is just one triangle, which is interesting. So yeah, it's kind of neat, I guess. But I want to, so I have this like, a partition is just a list of floats right now, but I actually want this to be its own object. So I'm just gonna like create a class for like a partition. Maybe this shouldn't live, maybe it should just be a class within collisions, but I'll just put it up here for now. So this will just have a list on it. But I'll also store other stuff like, I guess the min and the max position, just so I know where it is in space. Maybe I shouldn't call this min max because this is a function name. Call it that. And then, yeah, I can have it like, maybe this has its own init and free function too. A bounding volume. Yeah, all the libraries are from scratch. Well, I do use, there's two libraries I use that I didn't write myself, and there's one for loading image files. So I have the whole source in the description. Chat across streaming platforms. Yeah. But yeah, I have this full source there's like a GitHub link somewhere in the description. I'm not sure where it is on Twitch, but it should be findable. But yeah, so like the only libraries I use are STB image and then STB true type for font, loading font files. I have one in here for compression, but I don't actually use this at all. It's just in here because I was playing around with it. And then Steam obviously needs its own library. And then of course, like the graphics libraries, I'm using those. So I'm not like, I'm not doing a software renderer. It's using like the system supplied, libraries for like creating a window and doing like sound and networking. But I have my own like graphics abstraction layer, so I can do cross-platform development. But anyway, so let's get back to the collisions. So I want to move basically, let's see. Yeah, so partitions becomes a partition, and then this becomes a partition pointer. And these will just be vertices. And then, let's see, what else do I need to do? Yeah, so in the init function, we need some stuff. Let's see. It might be easier for me to do a 3D loop out of this, actually. Because I want to calculate the bounding coordinates and supply it to like the init function just so it knows where it is in space. Because I'm going to use that for the Raycast bounding box test. So I can obviously calculate the index from the function I wrote down here, which is why I wrote it. So we get the partition from that. But then we can also calculate the min and the max. From this. So like the min is going to be basically this plus x times partition size and the max is just the min plus partition size. We'll send this in. I say I hate shadowing as I do it right here. Oops. What build system do I use? So I have my own build system that runs, but I use Ninja build to actually like dispatch the compiler and the linker. I'm from the United States, so it's only well, it's 8 o'clock right now for me. In the evening. All right. And then let's go. So if I didn't mess up, this should all just behave exactly the same, which it does, which is nice. All right, and then I guess I don't need to print this anymore. Let's see. I've been programming for about 17, 18 years in total. But I'd say the last 10 to 12 of that are like actual productive years. Okay, so now I need a array against an axis aligned bounding box, and I don't know if I have a function for that in my engine yet, so I might need to look up the math for how to do that. So let's see, what do I have in here? All right, so if anyone knows off the top of their head if there like is a ray intersects AABB. I'm gonna do AABB 3D so I know it's a three-dimensional. Well, I guess it's implied by the fact I'm passing a vec 3. So we just give a ray, then we give a float 3, 0.0. I guess I can pass references to this. Because I actually don't know how to do the math for this, so I have to look this up. But I need this. Okay. So let's look up. Okay. 3D ray versus AABB. Ouch, my eyes. All right, see, we will shamelessly steal this guy's code and then test if it works. Let me think about what it's actually doing though. So He's doing the inverse, so he can do fast multiplication. He can avoid division here, which is smart. You get the inverse fraction, so you can do multiply instead of divide. That's smart. And then he's just getting the max. I don't use it that much. I try not to, because I like to think about what I'm doing. Okay, so I can do this. This seems pretty straightforward. So this is Ray. Fraction. So this is like vector inverse. So we have like a float v3. So he's basically just getting an inverse vector because multiplication is cheaper than division. So that makes sense that you would want to do that. So then what does he do? LB right top. So it's like bottom top. So I do const everywhere, even though it's not necessary, just because I like const correctness, if anyone's wondering. What is T? Where did T come from? Constants. Yeah, I should store it in the array. Yeah, so then you don't calculate it every test. Maybe I pass in the inverse for it. Would be the smartest way. What was T? Where did T come from? Does it say? And if you also length of array until intersection. Oh, that's interesting. All right, so I will keep that. I won't do anything with it though yet. I'll say distance or hit intersection. All right. Yeah, I will do as an output actually. That's a good idea. Yeah, so we'll do like a float, hit distance or something. That's a smart idea. All right, I'm just gonna delete his comments because it makes sense to me, and I don't really. Let's make sure this is all tabs. Yeah, it's a smart call actually. I'm working on collision detection. So I have this, it looks kind of crazy right now, but this is my level file loaded in as like, and interestingly, it's like stretched out. This is weird. Why are these not uniform size? Is it just the way the triangles have landed, maybe? But all these different colors are just like sections of my level geometry split up into partitions. And now I'm gonna do basically I'm doing bullet collisions. So when you like fire the gun, it has to do a raycast into the world in order to like know if it hit something. And like collisions for like game objects and stuff will need to use this as well. Or like if I'm doing audio and I want like audio to, I don't know, reflect off buildings or something. It's nice to have ability to raycast efficiently into the level. So I'm writing just the optimization for that system. And this is just a helper function for testing if I have a ray intersecting a bounding box, basically. So I'm going to add this In my debug, I'll add this to my debug stuff first, just so I can like sanity check that this is actually doing something. So we'll just put this in here. I'm just gonna change the color depending on if the ray is intersecting or not. So we'll have like a default color if it's not intersecting, which is like that randomized color you're seeing. And then I'll call to this. So we'll construct our little ray. Oh my gosh. So I'm just like constructing a ray. What's happening here? Why is it not liking that? Let's construct one of these from the camera. Actually, I think I store this as a vec3. I don't know why I'm not storing position as a vector. I keep like reconstructing it all the time. I should really change that. All right, so that's my ray. And then I'll also, I guess, store the distance for fun. So that if ray intersects the partition dot where is it? Min max. Let's get this in here. Need to include the header as well. I actually support a bunch of the APIs. So I fully support OpenGL, DirectX 11, and Metal currently, and I have Vulkan as a work in progress, but I haven't touched it in a while, so it still needs some work. All right, let's see. What's it mad about? Ray. Oh, I didn't add this. So if we intersect it, we'll just turn this thing white. All right, unfortunately, we are not seeing white, so something is not working. Interesting. Did I mess up? Max, I did mess up. All right, here we go. Yeah, so now as we like look across, you see how these cells light up? So that's the Raycast against, you know, the different partitions of the level. So now, like, if I want to actually do the full triangle collision detection, we can just test these white partitions instead of like doing the entire map. And we might want to also, I guess, test the neighboring cells as well, because it's like it is possible for a triangle to like, you see how this triangle on the right, this little bit there, it like juts out into the other partition, right? So like if I just test this one and I like raycast, I guess here, you see this would fail because it's like that triangle technically isn't in this partition because it's in the one to the left. So I might have to test the neighboring partitions as well as the current one. Unless I just duplicate triangles into all of, like maybe I add the triangle to every partition that it touches. So like, I don't know. I'm not sure. Or I could split the triangles if I really wanted to be like super precise about this, but I don't know. But yeah, I have other levels too I can load in. So here's like a more complicated level. I can't do daily streams. I'm pretty busy throughout the week, unfortunately, because yeah, I have a full-time job that I work during the like most of the day, and then I usually have stuff going on in the evening. So, unfortunately, I can't stream most days. Today I had some free time though, so I'm doing a stream. Let's see. This is actually just fun to play around with. All right, so let's write the actual Raycast algorithm now. So basically we want to have like a Raycast. I want a comparison function just so I can see the speed up as like a demonstration for why this is actually a good thing to do. So we'll do like Raycast partitions. This will be my new. So this is my naive collision detection, and then this will be our improved collision detection. So the first thing we'll do is, I guess, I don't know. Basic tools to make games in C++. I don't know, actually. I have bad advice for beginners because, like, I didn't start C++ as a beginner. So, like, I had already been programming a lot before I did C++. So I just transitioned into C++ from other languages. And, like, I used to use, like actual existing engines before I started doing my own engines. So, like, as a beginner, I mean, if you're interested in games, I don't know. Starting C++ games is difficult because it's like it is a very complicated thing to do. I think there are libraries out there that make it easier. So like you could use, there's a popular library called SDL, which is helpful for kind of doing a lot of the low level stuff for you. And then you could actually like get into doing game programming faster if you use SDL. So that's an option. But yeah, I don't know. Maybe other people in chat have better recommendations than me. Okay, why am I not getting highlighting? Yeah, I don't know. I mean, actually, I can comment on that. So I used to work at a AAA studio, and I worked there for about 3 years. And I was doing like graphics and engine code there. And yeah, that was very mentally taxing because I was kind of just like doing this stuff, but in a larger code base with more. Obviously, you have to be more careful when you're working in big code bases for stuff that actually has consequence. So yeah, I didn't. I was more mentally shot after working there all day. But I work at a different company now that's not in the games industry. Still doing graphics programming stuff and low-level code. But it's just a lot more, I guess, less intense. So I don't know. I still have the energy to code for fun afterwards. And I don't program every like single day outside of work. Like most days I just do like stuff at work and then I don't work it, you know, in my spare time. Because obviously there's balance in life that you need to maintain. Otherwise you'll just burn yourself out. Okay, so I'm basically just mimicking this draw debug function at the moment. So we need to get the partition index. It feels redundant to calculate it from the XYZ because I could just iterate over the one-dimensional array, but I want to test the neighboring partitions as well when I'm doing this. Hey, welcome back. Yeah, I remember you from, I think you were here yesterday, right? Remember? All right, so we get the partition, and then we'll do, let me think. I guess it's not just as simple as like testing the neighboring partitions, because the neighboring partition might be one that we're also iterating through. Like our ray is going to hit anyway, so maybe I want to hit like, well, I'll just keep this simple first and just test the ones the ray actually passes through, and then I'll deal with triangles that fall into other partitions next, because that should be easy to solve. So basically, we'd first do like if our ray does not intersect, let me get the partition. First partition, and this can be constant. So I guess there's two early out conditions. We can first test if, so like if this thing is empty, then obviously we don't have anything to do, so we'll just continue. And then if the ray does not intersect partition, it's kind of annoying that I have distance calculated on here. I don't really need it, but I'll separate these on different lines just so we know the logic here. I'll make this float max, just so it's really far away. So if we don't hit, we also continue. I've done streams over that time period. I haven't streamed consistently though. Okay, so if we have hit the partition, I'm trying to think, how do I want to do this? So we also have like we have a hit within the partition. So I have this hit. So then we will do the Raycast. So if hit ray intersects triangle list, so we pass our ray in, and partition dot vertices dot data. Do I need the actual count or size? I forget if it's count or size, because I think these should be implied. Oh my god, where's my IntelliSense? Yeah, okay. So basically, if the hit partition distance is less than our current hit distance, which I will set at the top of this function, if, I guess we'll say and, because we can simplify this, then we'll update hit to just be a copy of that. And then we'll return whether hit is less than float max. That will be whether we have hit anything. And this should be what? Oh yeah, it's just mad about the indentation. Okay, obviously we can't see if it's actually working yet. I think it should work though. So let's draw, let's just print some stuff to the screen for these 2 hits. So we have like 2, we'll have 2 of these. Partition. New line. How do you spell naive? Naive? So it's our naive approach. And I'll print the distance it hit just so I know like that these actually hit the same point. So we're going to time like the naive approach and then the time partition approach. And I'll print these out every second. Just so we're not spamming the terminal. All right, here we go. Are we getting the same value? We are not. Uh-oh. Wait, here we go, here we go. They look the same? All right, here we go. This is a good demonstration of why you should optimize your collisions. All right, so what happened? We have 2 different, we have the naive approach here on the top, which is we're testing a collision against every single triangle in the level when we cast array. And then the bottom one is when we use this partitioning system to like break up the grid, break up the level into smaller chunks. And you can see the naive approach in this specific instance here is taking 0.06 milliseconds for a single raycast. But the partitioned approach, which for some reason failed a couple times, probably because I'm at some weird angle. So we need to fix that. So that's one of the bugs I was mentioning, that these can differ if I'm not perfectly aligned. But the partitioned approach is at 0.004 milliseconds for a single ray. And besides the few times where it's failing to hit something, which I need to fix, you can see it's returning the same distance value, so it's hitting the same point. So if I go to a different level, which has more geometry in the scene, I think this should get a little more extreme. Yeah, so, I mean, I don't know what X improvement this is. And that's just like, I guess, the beginning of the optimization, because you can like optimize this even further. But yeah, it's a significant improvement in, like, what is this? A third of a millisecond versus, you know, 100th of a millisecond. So what, 30 times faster, roughly? Now there is a bug still, because sometimes you see this value goes up to some, I guess this is the max floating point representation. Oops, I crashed it. Every time I highlight in the terminal, it crashes. All right, so now how do I handle... See, here's an example of where it fails, right? So like, this is what I said, that the triangles sometimes overlap neighboring partitions because of the way I'm determining how they get split up. So like, this jagged edge, if I put my mouse over the blue part, and you look at the left where I'm like calculating the distance, it's not seeing any geometry there because it's not highlighted, so it's not like hitting it. And I'm getting this really big distance value. So we need to fix that. So I wonder what the best strategy for fixing that would be. I actually moved away from Visual Studio. Yeah, so Visual Studio Code actually does meet all my needs. And I've been actively trying to move as far away from Visual Studio as I can, because I don't like... Well, the problem is the debugger in the actual Visual Studio is really good. So like I still have it just for the debugger. But I don't really like Visual Studio as an IDE. For a few reasons. The reason I use Visual Studio Code, though, is because I do... this is a cross-platform engine. So I'm on Windows right now, obviously. But I also work on Mac and on Linux with the same engine. So like I can demonstrate that if I open up my little remote desktop tool and load into my Linux computer. Oops. So like here's the engine on Linux, right? And I can just use Visual Studio because Visual Studio just has like an official Linux version, you know, and I can just run the game on Linux. And I can work with the same editor and it syncs all my settings and it's like just very convenient. And the same is true for Mac. So like I just like Visual Studio Code because it's just like it works everywhere. So it integrates nicely with the sort of the build system I've created for the engine. But let me get out of Linux. Yeah, and I find like I didn't want to tie myself to like a Visual Studio solution file or anything like that, or their build system. Okay, my cat is on my desk. So yeah, I don't know. I use Visual Studio at work though, so. I never went as far as Vim. Or I have played with Emacs. I also use NeoVim, which I guess is like a fancier version of Vim because you can, I don't know, there's just more settings you can customize. So I used NeoVim for a little bit. But I'm not very good with keyboard shortcuts. It's just one thing I actually suck at is like memorizing keyboard shortcuts. And navigating like Vim relies heavily on keyboard shortcuts. And it uses a different like editing method. I forget what it's called. Cause like you know here, like you like click or whatever and you type and you backspace, right? And it's just like, I don't know. Whereas Vim is more, there's like a write mode and a delete mode or something. I don't remember. So yeah. Modes, yeah. It's like modal editing or something versus something else. I don't remember. I had a small phase where I was doing that. Maybe I still have it installed. I don't remember. No, it's not on this computer. Dang. Okay, this is actually an open question for anyone in here who has done partitioning before, because I'm sure someone in here has. How do you solve this problem with triangles that overlap into neighboring partitions? Maybe I should debug. I should add some debug outlines so we can actually see like the boundaries of these things. And I need to turn depth testing on as well. So let me add some more debug drawing stuff to this just as quickly as I can. Let's see. Where am I? What am I doing? Here, we need to do Add some depth testing. All right, so I'm gonna create a little vertex buffer for a cube. Let's see, how do I want to do this? I have this in a different project. Let me just find where I do it somewhere else. I don't want to spend time reinventing. Let's see. Do I not have outline code in this? I don't remember if this project works. I don't know if this compiles. Here's a little voxel game I wrote a little while ago. A little voxel renderer. The shadows are kind of broken. But I have in here some way of doing... How do I turn the... outlines? The 3 key binds outlines. Okay. I want these these debug cubes. I don't know what I did. It's been a while since I've touched this project. Okay. So 3. Yeah, 3 toggles. That. And I have a view frustum. All right, so where? I guess I just look in this project. Bear with me while I just get some old code. Draw octahedron. Oh, do I have a function for this already? Wow. What a crazy name, octahedron. I guess I'll use this. Oops. Oh, I didn't grab the whole function. Ah, of course I didn't. Sea lion. I don't have much experience with sea lion. I used it for a little bit, and I thought it was nice. You can just download it and start compiling C++, which is really convenient. I don't really know enough about how it works, though. I assume it has its own build pipeline, or maybe it uses CMake or something. Yeah, because I guess that's kind of the annoying thing with C++ is you have to like set up the compilers and stuff in order to actually make progress. All right, let me grab the actual code for this again. I don't know why I call this an octahedron. Is it because I have like multiple points? It's like an 8-sided shape, right? And I'm like passing in 8 corners. Bottom, top. Yeah, I pass in the bottom, top. And I'm just going to initialize a vertex buffer for this. Something similar to what I'm doing here. And I guess this will only ever have... How many faces does this have? 1, 2, 3, 4, 5, 6. I'm using like my old code here. command. For like UI for like in game, is that what you're asking? Let me test this function quickly. So I can delete that, and then I can draw an octahedron, I guess. All right, goodbye, kitty. Yeah, I can show. I do have a UI system. It's kind of an ever-evolving thing, I guess. But this one game demonstrates it because it actually uses it. So this is my other game I'm working on, which is like a Terraria clone. That's how I always start it. But this game has like UI widgets and stuff. So like this is like a little text box editor thing and buttons. So it has like scroll bars and all of this stuff, and like nested widgets. So there's the UI system, and obviously I have like the console, the terminal thing. So I can like change, I don't know, I have just a bunch of stuff in here that does the various widgets. Like I can change like the cloud color through here, and it opens up a new little widget. So here's like a widget that can basically edit a timeline of color curves. And this one's tied to the clouds as an example. So yeah, there is a, it's a work in progress system though, because like, I don't know, there's a lot of widgets I can support, so I'm just kind of adding as I need them. And like I have a different project that kind of has them in isolation, I think, this one. This compiles, let's see. Yeah, so here's like, the text editor is more of like a rich text thing. So this is kind of fun to write. So you can like copy and paste in this too. And it has different filters. So like this is numbers only. This is integers only, so I can't type. And then I have like sliders as well. Checkboxes. Windows. So yeah, it's a work in progress though. All right, back to the octahedron thing. Let's see. I want a version of this function that just takes in an AABB, just so it's easier for me to reason about. Drop it all into Vulkan. No, the music is, there's a friend of mine did the music a while ago. So that music's actually for the game I just showed you, the Terraria clone one. So it's one of the soundtracks. No, but the sound system, yeah, is programmed. All right, so I don't even know what to do. What is that emoji? I hate how I made this an octahedron. This is so annoying. Because like as obviously I did this so I can define each corner as its own unique point in space, which makes it technically more versatile. But when am I ever going to do that? So we just really need. And I'm just going to pass the width and the height or the. What's you have width, thickness, height? I don't even know. Size X, float size Y, float size Z. Sure, this will work just fine. So we have all of our points. We'll speed run these. Corner.x, corner.y, corner.z, corner.z. So bottom, I guess, would be x plus size x. And then we have I don't know what winding order this uses either. We'll just pass these on through. Over-engineered, why not? And I can just call this version down here. And we'll pass it the partition minimum. And I guess I can make this a float as well. Size, so that way size.x, so I can calculate this quickly. What happened? Attempting to draw a vertex buffer with a shader of a different type. What type does this expect? What is face? Is this not the same type? Oh, built-in vertex. Well, it kind of wants to work. Oh, yeah, depth. Yeah. I haven't heard about that until yesterday. The NVRHI. What'd I mess up? Size Z maybe? It's not taking T023. Yeah, I have a special version of Windows without all the bloatware that I definitely got legally. 100% bought it myself, completely legal. But if you want to legally get Windows with all the bloatware, there's a version called Windows LTSC, I think it is. And there's a website out there that has the ISO that you can download, and if you install that version of Windows, it doesn't have all the bloatware installed on it. All right. What am I doing? What's wrong? X, X, X. Y, 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 Y. Is this probably expecting an index buffer, isn't it? That's probably what's happening. Let me find the index buffer format, because I think I need that as well, unfortunately. So when I draw this, but I'm not, the thing is I'm not drawing it with an index buffer. So how is this even working? I certainly need one though, because I'm only giving it 6 faces. Yeah, very interesting. Yeah, it's true. What do I think if you use AI to program C++ game? I think you're not doing yourself any favors using AI to program your game for you. Is basically, oh, it's 6 times 6. Oh, yeah, that explains it. Obviously. Little typos here. This is what gets you. This should be 6 times 6 because there's 36 vertices in a cube. Here we go. Now we have squares. Nice. I'm at the point where I don't even remember why I'm drawing these. But, you know, it's nice to be able to see. I need to get like a good thumbnail for this. A good thumbnail for the live stream. Here we go. We gotta lock in here. Gotta fix the hair. What gun should I use for the thumbnail? Maybe this isn't a good thumbnail because people will be like, what the hell is going on? I need like fog or something so you can actually see. Why is everything glitching? Yeah, you're seeing the spatial partitioning of my level format. Here, I'm gonna make it look a little bit better though. So what do I need to do? I need to maybe give it a bit of transparency. We'll do less equals so we get blending. We'll re-enable the scene. That way people can kind of see what's happening. Not enough blending. So maybe we do like 127 just so we can kind of see the spatial partition. Maybe we need a different map for this. It's white because the ones that are white are the ones that my ray is passing through. So this is for collision detection. And as an optimization, I'm like splitting my level into basically these little chunks. And I'm just rendering the chunks as random colors right now so I can like differentiate them. And then the white chunks are just like my crappy debug to represent, you know, which chunk the ray is actually intersecting. So when I do collision test, it only has to check the white chunks. Is the idea. But I want to make the debug look a little bit better because it's always fun having pretty debug. So let's see. I want to do the intersection outside of this loop. So we'll have intersecting equals. So are we intersecting? Even though debug is really not necessary. Pretty debug is not necessary. Okay, so then we can do we can do this. It doesn't like that for some reason. What? Does this need to be What happened? What's happening? I can't tell if this is real error or not. I don't know what's happening. If intersecting, pick that or that. What? Is this the initializer list? I guess I just have to static cast this, even though it should be able to deduce that that's a U8, right, from context. Here we go. Now it's a bit prettier. And then we can do the same for the partition lines. So, I mean, if we are intersecting, we'll draw these as white, or let's see. Transparent, and then otherwise we'll draw them as gray lines, which you can't see. It looks like crap. Great. Looks good from certain angles. Yeah, auto could work too. I see why it's failing, because it's like, I guess it doesn't, it sees this as an integer, it sees this as a U8, because this is the return type. So then it's like, is this thing an integer or a U8? And it's like the fact that they're not all consistent is why. All right, maybe we don't draw these as a... We can simplify this. Do like blue and white. Or maybe we only draw the ones that are being intersected. It's almost like it's drawing with transparency. I would expect the yellow to be a bit brighter than it is. But yeah, anyway, so the moral of the story is that this is so much faster to partition, because naively it takes a long time, and the partition speeds it up significantly. So what I can do now is I can actually see here. Let's do it a true performance test of how long this is taking. So, or actually, let me do it with the particle. All right, I'll do it with the sounds first, because I added the sound system. So last stream I worked on this sound reverb thing, which basically if I'm indoors, I don't know if you guys can hear on the stream, but when I shoot, it's like the sound's kind of crisp when I'm outside, right? But then if I get indoors, there's more reverb. This isn't the best example because it's not very intense, but I can make it more intense. This will kind of kill everybody's ears. If I'm like up here, it's pretty crisp. If I go inside, it's very reverby. So if I add a timer to this, what just happened? And I like start the timer, and I end the timer at the end, and I just print out like sound update time. So how many milliseconds does this take with the naive case? I don't know why it's doing it twice. That's interesting. Oh, it's doing it twice per second. Yeah. So it's taking 6 milliseconds to do 100 raycasts into the scene, right? Because like here it's doing 100 raycasts in random directions, and it's taking 6 milliseconds in the naive case where I'm just testing every triangle. And if I load up a more complicated map, this jumps up to 28 milliseconds just to calculate the sound, which is insane. So what I can do instead is if I update this to use the new, I need to include level here. Which, so if I raycast against this with the partitioned, in theory this should be a lot faster. I mean, it's still kind of slow actually, but this was 6 milliseconds before, and now it's at, you know, half a millisecond, 0.5. If you guys can see, I can zoom in. So that's already a 12 times speed up just in partitioning, depending on, you know, where I am. Now if I change to this map, this was what, 28 before, and now it's about a millisecond and a half, which is still pretty slow though, because like 100 rays really shouldn't be that much. But as like a basic optimization, that's a good starting point. So I'm pretty happy with that. It's kind of cool because you can like shoot across the volume and just see the partitions. If I upgrade the Minecraft gun. Yeah. Bad bot. Okay, let's get the music back on. I'm actually not sure what else to work on at the moment. That's kind of the main thing I want to do tonight. Let's get the partitioning in. Which is fun. This feels wrong though. I guess it's because this triangle falls into this. So this is like a case where I need to fix the edges of like where the triangles get added. I guess the easy fix is I just add triangles if any point falls within the volume. And then not care about duplicates, I guess. It's just a performance optimization. So I can like shoot more rays without nuking my frame rate, basically. So I'm going to change my partitioning logic to, see right now when I create the partition, which is here, I just add it based on the center position. But what I should do is add it based on, the corners. So I will have like a usize each partition, each corner will just try to go into a partition. And then, so basically like, if, well, partition 0 will always get a triangle. So like, so we add the vertice to this guy, and then partition 2. So like, if this is not equal to this, because we don't want to accidentally duplicate triangles if we don't need to, then we'll do this. And then the last vertex will just check if partition 2 is equal to that, and it's not equal to index 1, just to make sure we're not triple dipping. I think this will work. It's kind of a dirty way because I'm like duplicating data, but it should be fine. So we can nuke this. And what happened? What? Add. Interesting indeed. Is this that weird edge case where we talked about if the point is perfectly on the edge, it will go into the wrong partition? I think that's what it was. Let me just sanity check that, is whether that's true or not. Where am I? I got lost. Okay, somewhere here where I calculate the min and the max, I guess. I can just, as a sanity check, let's like subtract 1 from the min and add 1 to the max, and this will ensure that we never have a triangle outside. But this is dirty. I need to actually fix the underlying problem. All right, let's see. Do we seg faults? Here we go. Now it works. Yeah, so now it's tough to see because it's like in a different color. But now the triangles kind of partially overlap their neighbors. So that's why you see these kind of, maybe this is a bad example, but there's a bit of a grid pattern that's forming around the boundaries. And that's just if triangles duplicate themselves across boundaries. What if I make the partition size smaller? Because like now I can fine tune this and see what a good value is. Like 64 is too small because it's like every triangle gets its own partition pretty much. And I guess you could play with the size and just like do some testing and see, you know, which value is a good value for these partition things. Oh, I didn't realize I'm influencing the randomness through doing this. I should fix that. I can't do this here because this my random number generator depends on the state. I'm sure the YouTube compression is like not liking this. So what's a good value? I think 128 was probably fine. That's surprising, because I'm not even streaming at that high of a bit rate. Alright, I'll move on from the debug view though in a second. I'm going to make this like a setting that I can just toggle. Because obviously this is kind of intense to look at. I'll agree. Try 96, yeah, okay, I'll do it. I like this map because it's pretty complicated. What is my cat doing? Oh my gosh. Here, say hi to the cat. Hello, kitty. Cat loves jumping up on the desk. Okay, so that's, yeah, spatial partitioning. Hi, cat. Yeah, maybe I should, like, alternate the colors, like a checkerboard pattern would look better. Sup, kitty? Alright, so I will just toggle this behind a toggle, because, yeah, it's kind of dumb to just draw this. So where am I drawing the partitions? Yeah, like, this would be in the level too. I'm not sure why I'm doing this here. Well, I have to do it here. So let's have a Boolean that can toggle this setting on and off. Up at the top, we'll have like all our debug stuff up here. And we'll tie this to a console variable, so I can just toggle it through the console. Oops, console. Yeah. I'm 27 years old. 27 years young. Okay, it's off now, so now it looks a bit better. Oh my gosh, my cat is just up here. I think he wants my attention. All right, so we can now just toggle this. See, it's up here on the top left now. I can just like turn this on, which is cool. Yeah, birth year 98. Same. You know, I'm starting to feel old because my birthday starts with a... My birth year starts with a 1. You know? I was born in the last millennium. Which on the internet makes you a dinosaur. Which is funny. I know, it's crazy. It's crazy. We're Unk status. It goes so fast. How did I get into this? I don't know. I've just been interested in this since I was a kid, basically. And I've been fortunate enough to be able to kind of continue doing it throughout, you know, my whole life. All right, I actually have some values in here for fog that I never turned on. So let me hook up the fog variables, because I have actually fog built into the shader, but I never set these variables. So let me add these to the... I guess the level would render these, or the scene, I suppose. So we have like some variables, static. What do we need? We need a fog color. Okay, hi cat. All right. And we'll hook this up to a console variable as well. And let's set these uniforms, which I had completely forgotten about, actually. Because I copied the shader from a different project of mine, so I actually had some of that built in. Where do I draw the level? So we just need to set the uniforms up here. Oh my gosh. Here, I need to go, I need to go move my cat for a second. He needs to take a little time out, maybe. All right, come on, kitty. As he runs off. All right, I'm back. Well, I'm working on it. Grandpa. What's the extension I use? What kind of library? Oh, there's so many questions. "2010 was 45 years ago. That's so right. What kind of library do I use? I don't use many libraries. I answered that earlier in the stream, so I'm probably not going to repeat myself. Otherwise, I'll get on a big tangent. What's my cat's name? My cat's name is Stinker. You remind me of Low Level a little bit. I don't know who that is. All right, let's get these uniforms in. Why do I call them shadow uniforms? These aren't shadows. Is that what I call these? Shadow uniforms? No, render globals. That's what I'm looking for. Yeah, here we go. You had to say no offense, so that could mean that's a bad thing. Fog color is fog color. And then we have to upload these. If I can type. Unfortunately, I have to end the stream in not too long. So this is probably the last bit of work I'll do before I have to cut it early, which is sad because there's actually a lot of people in here, surprisingly. I didn't think a nighttime stream would actually have so many people watching. Everyone knows Low Level. I don't know Low Level. Let me go. Let me see who this is. Maybe I do know who this is. Oh, this guy. Oh, I've seen him. Yeah, I've seen him in YouTube Shorts. Yeah. I can see why you say that. Oh, Tokyo Spliff. Yeah, I know Tokyo Spliff. He's pretty funny. I respect his grind. All right, does the fog work? Yeah, here we go. Now we have fog. The fog's affecting the gun very weirdly though, so maybe I don't want the fog being applied to the gun. I don't know what's happening with the gun. But the fog as oh, I need to do the offset Z actually. No, I don't need to do that. Here, let me turn the fog off for the gun though. Where do I draw the gun? The gun should probably have its own shader. Oh, that didn't work. False. There we go. He's kind of a crack. I mean, he does impressive stuff just by the way. Yeah, boomer shooter. You're right. Spot on. I don't know. It's just funny. It's entertaining watching Tokyo Spliff. And like he's pretty good at what he does too. So, like he obviously knows his stuff. It does seem like he kind of remakes the same thing over and over again over the years, but he like gets better with each iteration of his little project. So it's interesting to watch, the thing evolve. And like I saw he was doing Vulkan stuff recently, which is pretty respectable because I haven't even really done Vulkan yet. Of cocaine diesel? No, I have not. But here I can change the fog color. I have this little widget panel thing. Oh, when I click, I shoot, so that's kind of annoying. But I can get like a nice eerie fog here. And I can change the intensity with this slider. So that's fun. Fun to have little yeah, I can show that off. So I do have networking partially implemented. Here, let's get 4 players in here. Let's do the true test. So if we get 1 in each corner. Here we go. I should use the snap keyboard thing. So I can make the top left be the host. This is a client. And this is a client. This is a client. So you can see the networking does work. Obviously nothing really happens because you just fly around. But could it segfault? Is there a question attached to that? My code shouldn't segfault. I mean, it definitely can though if I've messed up. But I'm pretty careful about not having segfaults because those are bad. Yeah, prediction is definitely yeah. Obviously right now I'm doing nothing. It's just sending positions and rendering the other characters. So yeah, I need to actually do the netcode, which should be an interesting bit of content for the live streams. Yeah. I don't know how extreme I'll go with it either, because like at the end of the day, this isn't actually a game I'm going to release. Or at least I'm not going to release this in like some official capacity. It'll be, my plan is to put it as like a public, it's like the demo project for the engine. So like if someone clones the repository, this would be one of the demo projects that they can, locally compile and run and just see how I've like architected a game within the engine. But yeah, that would be a fun idea. If I do like the WebAssembly and the web GPU backend, I could get the browser versions working, and that could be a fun little browser game actually. because the low polygon aesthetic kind of fits, you know, the performance requirements of running in a browser. So yeah. Yeah, a lot of these assets are just like placeholder things that have accumulated over time as well. So it's like, I don't know, I just have random models sitting around. It's easy to load like low polygon models that don't have any complicated material system. Yeah, I can imagine. Yeah, I guess even it's lucky that, yeah, we live in the States. Because, yeah, definitely. Like, even prices are skyrocketing now in the United States. And I can only imagine overseas that have, you know, a smaller supply chain or higher, like, import tariffs are suffering, which is, which, you know, I kind of wonder what's going to happen to the gaming industry if this keeps up. Because, like, for a while, what people did, or what these developers did, is they just, you know, waited for more powerful hardware, right? So, like, these big game companies kind of stopped optimizing their games as intensely as they used to, because hardware was just getting so good and so cheap. But now that, like, consumer hardware is getting expensive again, I wonder if there's going to be some pressure to actually, like, optimize games. Because, like, if you want a game that's actually still advancing, you'll need to squeeze more out of the optimization than just, like, waiting for the hardware to get better. Yeah. Here, let me get the other game running. Because this game is... I want to show off my Terraria clone. Because I like this game too. I don't know why that build didn't kick off. Here, let me show off the multiplayer in this. Because I've also been working on the netcode in this game. And I need to turn on this. Debug. So this is my Terraria clone I'm working on. And this has networking in it. Which has been pretty difficult to get working. And it's looks to have broken. I seem to have disconnected from... Here, let me restart. Let's try this again. I like timed out through a LAN connection. I don't even know how that's possible. I wonder if it's the live stream messing me up. Yeah, but like the fluid simulation's networked, which is fun. This was a pain to get working, by the way, if you can imagine. Terraria dreams of these fluids. Yeah. Yeah, this game is definitely more impressive than the first-person shooter I'm working on. Because this is actually like a serious project of mine. I'm not just like messing around. So this one I'm actually being careful and like thoughtful about how I'm developing this, because I actually do want to turn this into a proper game that can compete within the 2D open world block game, Minecraft clone, Terraria clone space. So yeah. And yeah, the water isn't perfectly synced, because you can see there is some difference, because the water is simulated. So the way the water simulation thing works, basically in a nutshell, is that I locally simulate the water on both clients, right? So it's like it does a local simulation because you need that for the visuals. You need it so the water looks smooth as it moves around. So you need the local simulation because it's just too much data to send over the network. But I do have the water as like server authoritative, so that the server is simulating like the master copy of the water. And there's a heuristic that gets calculated that like if the water diverges too much in a chunk from the server's like ground truth state, then the server will basically force a resync of like any arbitrary chunk that happens to, you know, blow past the divergence threshold heuristic that I have implemented. And right now it's just a very basic, like, is the total mass of the chunk off by some percentage? That's the heuristic I use. But I want to make a better heuristic. But you can see it works pretty well. Like, the game's been running for a while and it hasn't had to sync because it's close enough. So, add politics. But yeah, if I like close one of these, go into single player. Oops, I spawned in a mountain. I don't know why I spawned in a mountain. Here, I need to reset the game. I have some bugs in the level loading code apparently. So I also have like lava as a fluid type, and oil as well. So there's oil, because I have this fun idea of like being able to drill for oil, and then you have this like kind of cliche oil well animation that plays from the fluid. Yeah, yeah, and I can like, so if I turn the chunk debug on, I have some values being printed, which, so the problem is, one of the problems with this is that the water state is actually, it takes up quite a bit of data just to like store all of the water state for a specific chunk. So uncompressed, each chunk has 64 kilobytes worth of water state that it needs just to simulate the water. So 64 kilobytes per chunk, which is too much to send over the network frequently. I mean, it's not impossible, but it's just like a high number. I don't want to be sending 64 kilobyte packets or streaming 64 kilobytes worth of data across the network all the time for like a single chunk. So I run a compression algorithm over it, which gets the size down pretty significantly, but it's still quite large. Like, you can see the chunks that have a lot of water. This is the compressed value. And it moves around because, you know, the water state is changing. But as these chunks get more complicated, like the size grows, right? And I actually don't know which compression algorithm it is actually using. So this is one thing I did experiment with a library for. So I'm using, let me find it. So I'm using the LZAV algorithm, which is like an open source header only library made by this guy. So I was just testing out a few different algorithms to compress, because I just wanted to see like how small can I get the data, because I do have to sync these chunks. So like if I can get these as small as possible, that would be ideal. Yeah. It's certainly a tricky problem to solve, the water stuff. And I mean, I have it working well enough now, so it's like, it's fine. But yeah, it's certainly something I want to think about as I keep working on this. Because it works pretty well for like low latency connections. And yeah, most chunks are empty. So like if I go up in the sky, and maybe if I make it nighttime so you guys can actually see these numbers. Oops. So like if I go up into the sky, the top number is the water data. So the compression algorithm does take up some fixed size just to like, I assume, store its compression state. So it looks to be about, 40 bytes or something, or like whatever that is in bytes. And the bottom number is the chunk block data. So as I like write blocks to the chunk, that one grows. Because I have to sync both of those. I have to sync the blocks, and I have to sync the water, the fluid simulation. And the fluid simulation number accounts for all three liquid types. So yeah, that's how that works. A much better debug view than the boomer the boomer shooter. Yeah, I agree. The boomer shooter is just like kind of a brain break type of project, because I've just been grinding this game for a few months. Like I did like a solid 4-month grind on this project just to like get all of the stuff actually implemented correctly. So I needed like, I didn't want to burn myself out on this, so I'm taking a bit of a break and I'm making the boomer shooter as like just another fun project, just so I can keep programming without, you know, burning myself out. This one's about a year. It's about like probably 7-8 months of actual work time, because I took a few months off from this project over the summer. But I started this one last January. And I didn't work, like if I look at my GitHub, my little GitHub graph here. Where is it? Hopefully I don't leak anything here. You can see I took like a solid chunk of time of just not doing anything over the summer. So, yeah. And I took that break because I really burned myself out last spring working on this in the engine. And I'm trying to avoid doing that this year. So I'm working on other fun things to keep myself entertained but not burned out. But yeah, I do eventually I do want to release this game at some point. It definitely has a lot more work ahead of it though, because obviously there really isn't much to this yet other than, you know, the world stuff works and like the fluid simulation works, which is one of the hardest parts actually, is getting all of that working, and like the save files work, so I can, I don't know, let's like create a save file here and like spawn some stuff. Like all the serialization code is all in. So like I can load up this session and here we go, we're back in. The world is not infinite, it's actually fixed size. And I decided to go fixed size, not due to any technical limitations necessarily, but because it's easier to make interesting world generation if I have... Yeah, I know, it is annoying. The problem is that if you have an infinite world, in order to have interesting world generation, you need to generate everything off of like a seed, right? And then you need to like place things in the world based on some function that's seeded by a value, right? So some deterministic function that will always produce the same outcome. And basically that kind of removes all the control you have over like the placement of things. Because like with that, it's easy to guarantee like, hey, every 32 chunks you'll have like a castle or something generate. But it's hard to do like anything more complicated than that. But with a fixed size world, I have a lot more freedom to like programmatically make the world interesting. And I thought that would be a better path to take the game, because I would rather the world be interesting than infinite. It's interesting how these clouds are like the same. No, Terraria uses doesn't it use like mono game or something in C#? I forget what it was made in. It was made in C# though. Or XNA, it was made in XNA, that's what it was. Which I guess isn't a game engine, so it has its own engine, but it's like a framework for C#, which is interesting. Yeah, that's correct. I don't know why I thought of mono game. That'd be impressive if they made that in mono game. Oh, but I also have a bunch of fun stuff. Like I have stained glass here. So the game has like a nice lighting engine. Let me find the glass. Yeah, so I can place like blue glass or green glass. You can see how it like changes the light to be more green. Or blue. I guess yellow doesn't have much blue in it. I used to have a red glass. I don't know what happened to it. If I go like time 12 and I remove the light, you get like some blue light seeping in. Radiance cascades, I think you're probably referring to. And the answer to that is no, I'm not. I have my own lighting system actually for this. It's one I came up with like years ago actually, and I've just been using it ever since. This isn't my first attempt at making this game, I should say. So I had a version of this game from like years ago, and I'm remaking it now, just in like a more proper way. But yeah, Radiance Cascades was after I came up with this technique. So I don't know. And I've decided I'm just like familiar enough with how my technique works. And my technique is pretty performant as well. Like it doesn't take up much frame time for pretty similar results. Make a paper. I don't have time to make a paper. Basically, I treat light like a gas, essentially. But it like has some rules. So like if I open up the light simulation light sources, maybe it's kind of hard to see. Can't make this any bigger. But basically I simulate light like a gas, and it like expands outwards from source points. Then there's rules so it doesn't like backtrack on itself. So that's how I can have stained glass that actually like shoots light downwards instead of like green seeping back up. So there's like a directionality component to it. And it's a grid-based simulation for the light, so it kind of aligns with the voxel grid that I have, or the block grid. I treat light like a gas. It's true though. I don't know how I can demonstrate it. Like if I make the speed here, I can demonstrate this if I edit the source code. I can show you what I mean by it behaves like a gas. Projects, vitality, runtime, simulation. Where's simulation? I should really use hotkeys for this. Okay, so here's my light update scheduler thing. So if I just make this like update very slowly, like maybe I do 200 steps of light update. You can see like already that it is actually quite slow. But if I like spawn in a point light, so I've like made the light slower. You see how it expands outwards like this? So it expands like a gas basically. And I just have enough update intervals per like frame that you don't really see the movement of it. But it is still moving, and that's just because the simulation kind of spreads out light like stepwise, I guess. Like it needs an it needs multiple steps in order to actually like propagate the light. And that's how this technique works. So like if I place like stained glass, we find the stained glass, you can kind of see how the stained glass will like shoot green light out. But yeah, the light update steps are so cheap because it's a very simple set of rules that I can get away with doing a lot of update steps basically per frame. These are like per second. So I'm actually updating it a ton of times per second. It's like 2,400 update steps of the light per second. But it's really cheap to run the simulation. It takes like a few microseconds. It's like 10 microseconds or something per update step, so like it's actually pretty cheap. So you don't notice it at runtime when it's set to the correct values. Poor man's ray tracing. Yeah. Exactly. So that's how that works. And unfortunately, that's pretty much all there is to this project at the moment. I do have a wind simulation. Yeah, so it's just like time based. So like I have this scheduler system in my engine, which basically just like tries to guarantee that this thing will run this many times per second. And it balances the load over frames, because you can see my scheduler is actually doing a few other things too. Like it's simulating the fluid at 90 steps per second basically. And then I do a readback. I don't know why this is so high. This should be 10, but I guess I'm doing a readback 30 times a second, which is actually insanely fast. I should really reduce this. This is kind of dumb. But yeah, I'll balance the load of these. But it kind of guarantees that like I get this many updates. So like even if my frame rate is super slow, like if I go in here and set my frame rate to be like, I don't know, 15, right? So now I'm like lagging like a slideshow. The water still simulates at like the correct rate, and the fluid and the light still simulates at the correct rate, I guess. So it has like a fixed time step, I guess. Yeah, most people don't notice. And I don't have weather, not yet, but I did spend a lot of time on this cloud system, so I'm like kind of getting there. So like I can, the clouds are like procedurally generated, so I can like increase and decrease the volume of clouds. And visually they look a little rough still because the colors are wrong. It looks a bit better at like in the evening time. But the idea is I can like change the cloud density and then also be able to change the colors of the clouds, so they're like lit by the sun in the sky, so there's like a bit of lighting going on. So the weather system will hook into this, and then of course I'll have like rain and snow and stuff. But yeah, this all just takes time. And the cloud stuff is interesting. Like I can show the debug for how the cloud atlas works. So like I generate these clouds procedurally, so they're all like unique shapes and they evolve over time. So the way I do it is I generate this cloud atlas at runtime and like kind of just dynamically draw these into the sky. But each cloud has like a unique shape. And this is actually a normal map. So I can I can do lighting on the clouds depending on the sun angle. But it's like kind of pixel art styled. So if I get close, you can see there's like pixel art and a bit of dithering. So it's not like photorealistic clouds. It's stylized. That's what I was going for, at least. Yeah. And my scheduler is just like really simple. It's like single threaded. I would want a job system with multi-threading though. I haven't gotten that far. Like the main goal of my scheduler is to just balance work throughout the frame so that my frame time remains as constant as can be. Because I don't want like poppy frames. But unfortunately I still do get those. So like if I could turn the profiler on, you can see I still do have like frames that are significantly more expensive than others. And this is mostly because of the GPU readback for the fluid simulation. So like these expensive frames are from the fluid sim. But my average frame time is pretty low. And it uses simplex noise, not Perlin noise. Do I think I can vibe code a game without an engine? Probably not. I think AI isn't quite at that stage yet. Depends what you mean by game. Can you like vibe code Pong? Probably. Maybe you could vibe code tic-tac-toe. But yeah, a lot of these background art, like the parallax tiles, are just like programmer art, because I don't have an artist working with me on this yet. You can make GT6, yeah. Well, and the other thing people don't notice, or I think people notice without noticing, is that the water simulation also does sound. So there's like dynamic sound to this as well, right? Like the splashing sounds. That was a really interesting problem to solve. Because it's not like I just get that for free, right? Like I actually have to I had to write code to try and interpret, the state of the fluid simulation and what sounds to play. Maybe it's too quiet on the stream to actually hear the sounds, but that was definitely a tough thing. And I think it adds a lot to like just the feel of the waters to be able to hear it. And I have an interesting debug for that as well. Like I can turn on, I think it's this debug view. So like this is how I do audio. So basically I have these little probes scattered throughout the scene that basically sample the water velocity field. And then based on the way these little probes kind of wiggle around like little springs, I use that to spawn in these little white spheres, these little white dots, which represent audio emitters. And then each of these is basically a sound effect. And the size and the volume is like the intensity. And like when the wave splashes, like I detect that by having these little probes like smash into the tiles. And then depending on the speed at which they collide with the tile, that determines like how loud the splash should be. So yeah, that's fun. But yeah, that's that game in a nutshell. But anyway, I am going to end the stream here probably, because I have to get going. I couldn't stream for too long tonight, so I can answer a quick question. How many splashdowns? I think I have like 8 of them that I alternate between, and they increase in intensity. So I have like 8 levels of splash intensity. So like small splashes create small splash sounds, and large ones sound more like waves crashing against the wall. Yeah, no 24-hour stream, unfortunately. But yeah, I'll stream again in the future, most likely on Sunday. So yeah, I'll see you guys then, hopefully. If anything comes up, I'll make a post on the little YouTube thing maybe. But yeah, see you guys.